In the previous video, I have finished discussion about hypothesis test, and we are going to start the confidence interval part. And actually, the confidence interval part will be really brief because it is almost the same as what you do for the hypothesis test. So they are, like say, the flip sides of the same problem. So it will be pretty quick to discuss, to introduce the confidence interval. And as usual, let's start from the general framework and reviewing the general framework. Confidence interval is usually given by like this. There is an estimator beta hat, and beta hat itself does not tell you how accurate the estimator is. So to supplement the information, you add and subtract a certain margin of error. M is the margin of error that shows how accurate you are. If the estimator is very accurate, you don't need to have a large margin of error. So the margin of error will be narrow. But if your estimator is noisy, uncertain, and unstable, then you have to allow a large margin of error to interpret the results. Therefore, the margin of error is closely related to the standard error of your estimator. And so this is confidence interval, and I understood it as that when you estimate beta, you are confident that the true beta lies between those 2 points, lies within this interval. So I think that's why it's named as the confidence interval. And also there is a confidence level, another term, confidence level, which means the probability that the true beta lies within the interval. So usually it is 90%, 95%, 99%. As you can expect, the standard is 95%, which corresponds to the significance level of 5%. So in this case, this means I think the true value will be on this interval with 95%. So if you conduct estimation repeatedly, then only once in 20 times you get wrong. But if you don't want to allow any potential error, then the only possible option is to widen the margin of error. And then when you widen the margin of error, the information is washed out. So in the end, if you widen the margin of error too much, then it means nothing. There is no information in a large interval. So keeping the interval smaller is helpful to deliver more information. But at the same time, of course, you want to increase the confidence level, the probability of the estimation accuracy, like the how likely your estimation is correct. And then why did I say the confidence interval is a flip side of hypothesis test? Think about this. Consider this hypothesis. Beta, you believe that beta equals to beta 0. And suppose that it is not rejected. And that means if this hypothesis is not rejected, that means this value is not much different from beta hat. Remember, you reject the hypothesis only when your hypothesis and the estimator are too different relative to the standard error. So then conversely, if a hypothesis is not rejected, that means the value is close enough to beta hat. So if you collect the values of beta 0 that is not rejected, then you can make an interval of them, or interval from the collection of beta zeros, non-rejected beta zeros. So that is that is equivalent to the confidence interval. So if beta 0 lies between these points, then it is not rejected. Then this becomes the confidence interval. In that sense, the hypothesis test and confidence intervals are basically the same problem. And the margin of error is proportional to the standard error. And in the regression model, the idea is the same. It's from the data you estimate the point, but at the same time you would like to allow a certain margin of error, which admits the potential errors and tells about how accurate your estimator is. And 95% confidence interval is calculated this way. The point estimator, 1 point estimator, plus minus 1.96. You remember this number? This is 1.96 compared with the t-statistic. It's the same number. And usually this is approximated to 2. So usually in practice, beta 1 hat plus minus 2 standard errors, which is not much wrong, or like commonly used as 2 standard errors. So you have an estimator, and you have to allow 2 standard errors on each side of the estimator as the margin of error. So you can expect at most 2 standard errors from an estimation, right? And then as you have seen before, it is easy to calculate from Stata results, because this is calculated by Stata and this is calculated by Stata, and then multiply, add, subtract, which is pretty simple. So then that means the effect of student to teacher ratio on the test score can be up to minus 3.3 points, or at least minus 1.26%, minus 1.26 points. So it could be noisy, so the estimator may be noisy, may have errors, but just approximately, the approximate range of the true value will be here, which is correct 19 times out of 20. Then, as I said, the statements are equivalent. The confidence interval, any points in the confidence interval is negative. So that means it is clear that the effect of student to teacher ratio on the test score is negative. It is not zero nor positive. So that's how we interpret the confidence interval. And so now let's look at the result. The confidence intervals are calculated here, and again the 95% is given because that is the standard. So it shows that the point estimate, if you need one number, that's this guy, but you have to allow certain plus minus margins. So you have confidence interval from here to here. And now here is how to report the regression results. So far it took like more than a month to tell you what this table means. So I gave you a lot of theories, but all of them are to understand this table. Now I have explained everything in this table. So, and then the next problem is, when you write, you cannot simply copy and paste. Never do that. Especially when you write a formal report. Term paper is also a formal writing. So never copy and paste or screen capture and paste are not allowed. That's not never allowed. So then how can you report the results? One simple way is like this. Just tell that you are using test score. You are using test score on the left hand side, and it can be predicted by this relationship. So this tells the estimated regression equation. So, and it also tells what is the regressor here, student to teacher ratio. Of course, you need to somewhere before or after this equation, you have to define what STR means, right? You have to say that STR is it means it is the random variable of the student to teacher ratio. And in the parentheses below, you can put the corresponding standard errors. So standard error for this intercept is 10.4, and the standard error for this coefficient slope is 0.52. So also so this part I think is the most important part. And in addition, you can report R squared. R squared is 0.05. 5% is explained, and standard error of the regression is 18.6. So it means the error term, even though it does not show up here, the error term has this much variation. So you know what is what from so you can take those numbers, report those numbers, and also take this number and so a root mean squared error. So standard error of the regression is reported here. Root mean squared error, I explained why root mean squared error is this guy. The textbook definition and Stata definition are different, which is really annoying, but I have no power. So anyhow, we are reporting these two numbers and these numbers. And you can interpret these guys, and also you know how they are constructed. So this is how we interpret the results. In the next video, I'm going to consider additional topics, a little bit. It's really, of course, about the regression model, but some less serious topics. So see you there. Bye.